Hey, calculus students, Mr. Klein coming at you without a hat, strangely enough. Just kidding, of course I have a hat. It's fun. Today we're going to be talking some more about limits, and specifically limits that involve my buddy infinity. I happen to have just such a function here, limits that will involve infinity, and it is f of x equals 5 divided by x minus 3. How do we know that there will be some limits involving infinity? Well, we know there's an asymptote. How do we know there's an asymptote? Well, there is a factor of x minus 3 in the denominator that is not a factor of the numerator, which tells us that there must be an asymptote at x equals 3. I've gone ahead and drawn that with a red line right here. Now let's get a few more points that are on the function. I'm pretty sure that if we plug in 4, let's see, plug in a 4 there, 4 minus 3 is 1, 5 minus 1 would give us 5. If we were to plug in, say, 5, we would get 5 divided by 2 minus 3. That's 5 divided by 2. That's 2.5. So 2.5 would go right here. What if we plugged in, I like 8. So 5, 6, 7, 8. We plug in 8. 5 over 8 minus 3 would be 5 over 5, which is 1. You can see that the function is decreasing in this direction. Let's go one more over here. What if I plugged in 3.5? 3.5 would give us 3.5 minus 3 is 0.5. 5 minus 0.5 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Graph sure appears to me like the values of it are getting very large over here as we approach 3. So the question is, what is the limit as x approaches 3 from the positive side of our function? And I want to look at this question by evaluating our function at a few points that are really close to 3 on the positive side. So let's suppose that we chose 3.1, 3.01, and 3.001 as our values. So when we get the calculator up, in the calculator, under y equals, you want to type in 5 divided by the quantity x minus 3, has to be in parentheses. And then you're going to click over here to the table, and if it's not empty, oh, by the way, if you don't remember, you have to go to table set and then ask. This has to be set to ask, or this won't work. And let's choose 3.1, 3.01, and 3.001. Now, I want to impress upon you what is so amazing about what just happened. At 3.1, we're at 50. We moved to 3.01. That's like 9 cents. By moving by just 9 cents, the y value increases by $450. Now here, from here to here, look, we moved by 0.9 of a cent, less than a penny, less than something you would not pick up if you found it on the ground. And the y value increased by 4,500. So very, very, very small changes in x are leading to larger and larger and massive changes in y. In fact, we'd say that as you move closer to 3, the y value is going to get big as you want. And if moving your x value close to some value makes your y incredibly, incredibly, incredibly large, that's when we say that the limit is approaching infinity. In this case, a positive infinity. You'll notice that I don't put an equal sign in here. Your book does use an equal sign. I use an arrow because I don't think you can be equal to infinity. Infinity is not a number. All right, so if we can make this function as big as we want by moving the x value closer and closer to 3, here's a question for you. If the function is greater than 1,000,000, what is x? Here's what I want you to do. Pause the video, mess around with that for a little bit, and then when you come back, we'll get our answer. So solutions, I did it this way. I took f of x and I replaced it with the function, with 5 divided by x minus 3. And then I thought of it this way. You know, this is sort of a proportion. You got a fraction here and a fraction here. So you can swap the 1,000,000 and the x minus 3, which is going to give you 5 over 1,000,000. And then on the other side, you're going to get an x minus 3. And if you solve that, this right here gives you 0.000005. If you add the 3 on, you get that x must be less than 3.000005. We should also add that x has to be on this side of the line. So x is going to have to be larger than 3. There's our answer. Boom, 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 boom. What about if we picked this side of 3? So what about if we are taking the limit as x is approaching 3, but from the negative side? Well, I can get that out of the calculator too. Let's pick some values that are close to 3, but smaller than 3, like 2.9 and 2.99, one of my favorite prices, and 2.999. This time we are getting -50, -500, -5,000. The numbers are getting really big again, but this time they are approaching negative infinity. So the curve is going to look something like that. And if you can make the y value really big and negative just by moving your x value, that means you are approaching negative infinity. Okay, so let's do one more. And I'm going to kind of change it up here. This time I'm going to say, I'm going to change the color. Let's go green. We want the limit as x is approaching infinity of our function. So the infinity is in a different place here, right? It's the x value. So this is saying as we put really, really, really large values into our function, what is the output going to be? Well, I think it would make sense to build a table here again. So I'm going to make a table. And in this table, I'm going to put in the values 10, 100, 1,000. So what it looks like is we are making the x value 10 times as big. That's a sensible thing to do when you're moving towards infinity. And then I'm going to put these 3 x values into the calculator now. 10, 100, 1,000. And I got that the value of the function is 0.7, 1, 0.05, and then 0.005. So as the x is getting big this time, the f of x is getting close to 0. Therefore, we can say the limit as x is approaching infinity of our function is 0. 0 is a number. You can put an equal sign in. Well, let me ask you a question about that. If this thing is getting closer and closer and closer and closer and closer to the x-axis, to 0, as x is getting large, then if f of x is this tiny, it's less than 0.001, how large is x? So let's just work this one out together. It's going to be similar than the last to the last one we did. You can replace f of x with what f of x is equal to. And same game as we did on the last example like this one. You want to think of it as a proportion, and then you're allowed to swap the things that are on the diagonals when you have a proportion. So this is the same as 5 over 0.001, and then x minus 3. Now, 5 over this is going to give us, let's see, you got to move the decimal place over 1, 2, 3 spots. So that's 5,000. Then x minus 3, which means that x has to be larger than 5,003. Boom, 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 boom. And that's the game.